Alright, hey everybody. So this assignment, Introduction to JavaScript, when you get to it, I think it's pretty self-explanatory. This course is, there's instructions in it and everything to tell you exactly what to do. But, I don't know, I just didn't want you to feel like I was just throwing you into the deep end and abandoning you. So, I thought I would make this little video where we just kind of do the first part together. When you were developing Scratch games, according to Al Sweigert's instructions, you learned what a variable is. You learned a little bit about loops and if statements. And most importantly, I hope you learned a little bit about how to think like a computer. We're going to be making games in JavaScript, so I thought it would be a good idea to take a JavaScript course. And that's the one that we're going to take. So, if you'll remember, when you, I think when you were making the basketball game in Scratch, you had to make variables, and I think one of your variables was called velocity, and you named that variable. You named that variable velocity, and then when you wanted to refer to that variable in the code, you would just you would use that name, and the value that was in velocity would change according to your instructions, and that's what made it look like there was gravity in your game. And I know you guys made a lot of if statements, right? So that's where the computer does something differently depending on whether this happens or this happens. And I think you used that in the maze game. When your little cat ran into a wall, I think you used a statement something like, if the cat is touching the wall, then don't let them change their position anymore. Keep pushing them back to where they were, and that's what made it look like the wall was blocking your way. Yeah, of course it wasn't. If we would have just changed the code, the cat could have walked right through the wall. Loops. I think you used some loops in Scratch. And I don't really remember any examples, but a loop is where you say, okay, computer, I want you to do this over and over and over and over and over again forever until something happens. And sometimes we use loops, in a game that you can win. Sometimes we use loops to say, okay, computer, keep running these instructions for the game. Let the player play the game until they get a certain number of points, or until they kill the boss, or until, whatever the game win condition is. So loops. There are while loops. There are also for loops. For loops are when you want, maybe you have a collection of things and you want to do something to each item in that collection. Then you might use a for loop. Okay? And that's going to be where we probably didn't use that stuff a whole lot in Scratch, but we'll use it a lot more in JavaScript. So let's go on over to Codecademy and log in with your, I'm already logged in, but it should give you an option to log in with Google. Make sure you use your PSA Google account. And you want to go to this magnifying glass here, and you want to search for Introduction to JavaScript. And here it is, the very first one. So click on that. Read the overview and the syllabus if you like. A quick note. You'll notice that it says time to complete 30 hours. I don't know if this actually would have taken us 30 hours or not. I am thinking that maybe we won't do this whole thing. And that's different than in these instructions. Originally I was going to have you do the whole thing, and then I said print out your certificate of completion. I think we might stop after Module 9. The rest of the stuff, I don't really feel like it's super important for what we need to do. And the nice thing about Modules 1 through 9 is that it's good information about programming in general. This information 1 through 9, you could take this and go apply it to any other language or situation. I don't know about 10 through 14 though, so we'll make 10 through 14 optional. But I'm sure you guys want to get started on your actual final game. I mean, that's what this whole thing is for, so you guys can make a game. I'm sure you want to get started on that as soon as possible. So, again, I'm not saying this is how it is yet, but my thinking right now is that we're just going to do 1 through 9. Alright, so let's go and start this bad boy. When you're looking at this, there will always be something to read on the left, and then a place for you to type code in the middle, and then a place to see the result of your code on the right. So here's the introduction. Here's where the instructions are going to be for your exercises. The cheat sheet, this is kind of like if you wanted to look up, you look up definitions in a dictionary. Well, the cheat sheet is kind of, well, let's just go there. Cheat sheet is where you kind of get like a little description of all of the different things that you can do in JavaScript. Basic stuff. Booleans, let things be true or false. This is how you do a random number if you ever want to do a random number. This is how you make a comment. I don't remember. I don't think you made any comments in Scratch. I think you just wrote code. Anyways, we don't need to look at this too much right now because I think they're going to explain it in the course. So, the instructions are, move to the next exercise when you're ready to begin. So, click next. Alright, read this about the console. And they did a good job of explaining it, but basically when you write all this code, the computer is going to execute line 1, and then it's going to execute line 2, and then it's going to execute line 3, and then line 4, and line 5. And it's going to keep going on like that unless you tell it to do otherwise. Okay? If you write an instruction on line 5 that says go to line 10, well then it's going to skip line 6, 7, 8, and 9. And the problem is, really the problem is that almost no human ever writes their code perfectly the first time. And so inevitably when you write your code and it doesn't work, you're going to want to know where the code is not working. And that's why it's really helpful to embed these little console.log statements. The console is the thing that we're controlling, and the log is what they call a method. Okay, so this is the noun. This is how I think of it. If this is confusing to you, don't think of it this way, but this is how I like to think of it. This is the noun. This is the thing we're controlling. And this is the thing that we're telling it to do. So, you know, imagine you had a little puppet, one of those marionette puppets that has the strings on it, and you control it from above, right? So this would be like the puppet. Puppet is the thing we're controlling, and the method is the thing that we want it to do. So maybe it could be puppet.jump or puppet.smile. I don't know if they can actually make them smile or not, but puppet.wave, puppet.kiss, whatever. Okay. And in this case, we're going to do console log. What do we want it to log? We want it to log our age. Mr. Carter is 100 years old, so we'll try that out. So you write your code, and you come down here and you click Run. And this is what the computer would show you. It doesn't show you all of your code. It just shows you this thing that you told it to show you. And what's helpful about this information is that if we see this 100, then that means that line number 1, that the computer got to line number 1 and it executed line number 1. If we click Run and we don't see this, then that means that it never got to this point. And that can be very helpful information. Alright, on the next line, log a number representing the number of weeks you've been programming. It's going to be another console.log statement, and gosh, how many weeks have I been programming? I've probably been programming for about 6 years. 6 times 52 is about 6 times 50, 6 times 5, so about 300 weeks, give or take. And 300 spits out. So now that all of my parts of my instructions have green check marks on them, that means that the lesson is done. And this next button turns to yellow. It was not yellow before. I think it was gray. It means you cannot pass. But now it's yellow, so I can pass. Okay, read this thing about comments. And you know, this is really the gist of it right here. Computer code is hard for humans to read and understand. Even if you're professional. It's hard to take a quick glance at all this and understand, you know, what is going on. And so what we always do as good programmers is we kind of like how you know how some people, they put notes in their textbook. Like if you're in a college and you actually buy your textbook and it's yours, you own it, you can write notes in the margins. Well, comments are our way of writing notes to humans, but the computer will ignore it. And anytime you want to make a comment, you just type 2 slashes, and then anything that's after that on the same line is a comment. Once you go to the next line, then the computer's like, oh hey, this is a new line, it's not a comment anymore. If you do want to write like a really long comment and you don't want to click those slash or put those slashes at the front of every line, you can use a slash and an asterisk, and then an asterisk and a slash, and that tells it, hey, comment starts here and stops here. This is interesting. Now, I've never actually done this, so that's interesting that they're saying this. You can use this syntax to comment something out in the middle of a line of code. I don't know why you would need to do this, but you can. Now, another thing we use comments for, besides making notes to human readers and making notes to ourselves, sometimes you want to turn a piece of code off, especially if you have something working and then you add some code and it doesn't work anymore. Well, you might want to go back and turn that code, the new code, off, so that you can try and figure out why it's not working. And what you can do is you can wrap, these comment things around that piece of code, and then the computer will just ignore that piece of code until you turn it back on. On line 1, write a single line comment that says opening line. Boom, line 1. Comment needs to say opening line. How do we make this a comment? Well, we just put two slashes at the beginning of it. And you'll see that it turns gray. Now, I don't need to talk about that right now. In this class that you're taking, in this course, at this Codecademy.com thing, in this little editor that they've provided you with, you'll notice that the words turn different colors based on different things. And that can be very useful information. So, if you type something and all of this turns gray, well, then you know that the computer thinks that you wanted this to be one big comment, and it's not going to run your code. So if the computer's not running something, and you go back and you see that it's all gray, well, you might have accidentally put this instead of two slashes, and now it thinks that this whole thing is a comment. So pay attention to the colors. Alright, so click Run. This shows you the results. This shows you whether the computer likes what you typed or not. And it does. Green, or the white check mark on a green background means that it likes it. You can move on. Alright, 1, 2, 3, 4, 5, oops, the bottom 6. That's down here, I guess. Okay, start a comment, end a comment, run. And now you'll see that over here, the computer, the result of your code was that when the computer was printing things, it just ignored all of these console.log statements. Alright, so all check marks. The next button has turned yellow, which means you may go to the next lesson. Alright, data types. Data types are very important. I don't remember if we work with data types in Scratch or not. But, a number is different than a sentence. And human beings are smart enough to figure out, usually, human beings are smart enough to figure out when you're talking about a number and when you're not talking about a number. We know from the context. Unfortunately, computers are not that smart. So sometimes when we're working with numbers, especially when we're doing math, we have to tell the computer, hey, this is a number. It's, sometimes when we're working with sometimes when we're working with text, we have to tell it that this is text. So read this about the different types of data types. Read it. If you don't understand it, that's fine. I think this is going to be one of those cases where you learn it as you do it. And I want to draw your attention to number 7, object. Objects are super important in especially in advanced programming. And you'll hear about objects all the time. I like this description of objects. What is an object? An object is just a collection of these things. Okay? So if you have multiples of these things and you bundle them together in one package, then you get an object. Again, you'll probably learn more about that just by using them. So when we're dealing with text, you read above that text is referred to in computer programming as a string. That might take some getting used to, but get used to it. Let's get comfortable with strings and numbers. So on line 1, log the string JavaScript to the console. So we want to tell the console to do something. What do we want the console to do? Well, we want it to log something. What do we want it to log? We want it to log the string JavaScript. Now I don't recall. I might have. Just like we would put a period at the end of a sentence, when you're done with a single instruction for the computer, you're supposed to put a semicolon, right? That tells the computer, this is the end of this statement. Just like a period tells humans this is the end of a sentence. Now, beginning programmers almost always forget to put this on here. We're just not used to doing it. But try and get in the habit of putting that semicolon on there. Sometimes your code will work. Sometimes it won't. If you leave the semicolon off, I mean. If you forget, maybe the computer will be able to understand what you're trying to say and it'll be able to do it anyways, but maybe it won't. So always try and put those semicolons on there. And let's check that code by running it. And there you go. The computer likes that, as denoted by this check mark. So let's go on to the next instruction. Okay, the computer likes that. Now, they're probably going to talk about this later anyways, but I just want to point out that when you and I see 2011, we would probably immediately just assume that that's a number. In computer world, well, that could be a number, but it could, if you put quotation marks around it, well, then it becomes a string, and it's not going to treat it like a number anymore. And I hope I'm not getting ahead of the class here, but you know, if you put 2011 plus 2, then you're not going to get 2013. What are you going to get? It's just going to take those two things and literally put them together. 20112. So numbers, if you want it to actually do math, you need to put it like a number. And there will be some times later where we don't want it to do math. We want it to actually treat it like a string. All right, on line 3, print. Woohoo! I love to code. Try not to forget those semicolons. And run. If you ever make a mistake and you get a red X, you can look down here, and a lot of times it'll tell you to check something. Now, I haven't found those comments to be very helpful, but it will try to help you. And another thing, what if you can't get it? What if you type in the code and it keeps giving you a red X and it won't let you move on? Let's simulate that right now. On line 4, print the number 20.49 to the console. So let's say you do what you think you're supposed to do. I don't know. Let's say you do something that you're not supposed to do. Console 20.49. Okay. So you think this is correct, and you run your code. Oh man, and of course it says no. Well, it's going to try and help you out down here. Did you put a number in your console.log statement? Well, you know, you might notice, oh shoot, I didn't put console.log. That's what I did wrong. Of course, that's not what it's telling you to do. It's telling you to check the number. There's nothing wrong with the number. It's the same number. So, like I said, not particularly helpful. But what if you just cannot figure out what you did wrong? Well, what you can do is you can come down here Now, you know what? Maybe it doesn't show it to you until you... Okay. Let's get it wrong a few more times. Console dot output. If you get it wrong several times, then you get this option down here to view solution. And if you click on that, then they will tell you the right answer. Give me the solution to this exercise. So now it's been changed to the right answer. And you can see where you went wrong. Oh, shoot, I wasn't putting the console.log statement. Well, now I know for next time. And then that will give you, it's perfect. It's the perfect answer, so it gives you all green check marks, and then you can move on. So I suppose you could just keep hitting this view solution and get through the whole course that way, but then you wouldn't learn anything. Remember, that's the point. To actually learn this stuff, be able to go do something with it. Alright, again, instructions on the left. Sorry. Information on the left. Instructions down below the information. Now, we're not always going to be using console.log. We're just using it right now because, like I said, this code will run invisibly to the user. This console.log is the way that we make this visible to the user right now. So in order to see the results of our work, we need to use this console.log statement right now. Add 3.5 to your age, so 100. Mr. Carter is 100 years old, so adding 100 to 3.5. Don't forget that semicolon. Run. Enter. And if you don't want to move your cursor all the way down here to run every single time, there's a hotkey, Control plus Enter. So hit Control plus Enter and it'll run your code. And it's really good to get used to using hotkeys. They speed things up. The problem is you just got to remember them all. Alright, one other thing I want to point out here. The reason that people invented Scratch, okay, this kind of programming that you're doing now with JavaScript, of course, that was they've been programming like this for a long time. Scratch is fairly new. That idea of having little blocks of code that you drag out onto the stage and click together. And they came up with that mainly for kids, because kids have a hard time with programming like this. You have to know how to spell words, and if you don't spell words correctly, then your code won't run. And that's why they invented Scratch, is because if the blocks of code are made for you, then you can't misspell things and you can't make capitalization mistakes. And all of that stuff will screw up your code. What happens if we misspell console.log? Is the computer going to be able to figure out what we mean? Control Enter. No, it does not like that. And in fact, I bet even if we put a capital C, I actually don't know what's going to happen here, but what if I put a capital C here for console and I run it? Still doesn't like that. So if you make even one little tiny mistake, the computer will throw a fit. And that's part of the reason computer programming can be so frustrating. I can't tell you how many times I've written some code and it didn't work, and I spent hours or even days trying to find the mistake. And eventually, you start thinking, well, maybe there's something wrong with my computer. Because my code is perfect, so there must be something wrong with the computer. It's never the computer, folks. It's always your code. You literally gotta look at it, every single letter. And sometimes it's just, I leave off a semicolon. Sometimes it really is as simple as that. Or I leave out a comma or something like that. So it's really important. I have students in my classes that they say, "Oh, Mr. Carter, why do I have to capitalize everything? You know what I mean?" Or, "Mr. Carter, why do I have to do this? You're being extra." Well, being able to focus in on these little details, being able to see the little differences between things, is important, especially if you're going to be doing some programming. Alright, so let's put that semicolon on there and run it. I think one thing that they're trying to, they're just trying to get you to use these operators. They'll probably point this out later, but one thing I'll point out real quick is addition, use the plus sign; subtraction, use the minus sign; multiplication, use the asterisk; division, use the slash; the remainder, you use the percent sign. This is kind of a weird one. Sometimes in programming we don't even call this the percent sign, we call it the modulo. I don't know if I'm even pronouncing that right, but it's M-O-D-U-L-O, modulo. And so this would be like, the main reason we use this is sometimes, like if we want the computer to check if something is even or odd, right? Then we will divide it by 2, and if there's a remainder of 0, then it's even. If there's a remainder of 1, then it's odd. Another way we use the modulo is basically if you want to figure out if something is evenly divisible by a number. If you want to figure out if a number is divisible by 3, well, then you just check and see that when you divide it by 3, is there a remainder of 0 or is there a remainder of something else? Alright, our next button is yellow, so we may proceed. Alright, so we're going to put these two strings together into one string. And you'll notice that in the example it uses single. I mean, you may know it as an apostrophe, but in programming we usually call this single quotes versus double quotes. And in some programming languages there is a difference. It will treat it differently. But actually, I think in this one you can use either for now. Single quotes means string, and double quotes means string. So even though it says single quotes over here, I'm going to try it with double quotes and see if it likes it. Yeah, it likes it just fine. So you can use double quotes. Now the one thing you cannot do is you cannot mix quotes. You cannot come here and do a single quote here. Okay, I can't. Okay, so here I have double quote, single quote, double quote, double quote. If I try to run this, I guarantee you it's not going to work. Well, shoot. It already checked this off my box. Let's try this experiment with the next example. We left off on the space last time. Create a second console log segment. Alright, so there's our output for the first line. Let's try console log. Hello. And what they're trying to tell you is that, see, there's no space here. So when you're doing this stuff, sometimes you need to think ahead. You need to put a space at the end of these words. And so I put a single quote here, and all the rest of these are double quotes. And if I run it, I bet you it will not work. Yep, it will not work. So you can choose single quotes or double quotes, but you have to be consistent. And we'll see why that is later. Okay, so here's our string. Here's our sentence, our piece of text. And we want to get a property of that string. What is the property that we want to get? Well, we want to get its length. And try not to forget that semicolon. So here's our string. We want to get its length, and then we want that to be logged to the console. And you'll notice it prints out 30. It doesn't print out teaching the world how to code. Because we're not printing this string, we're printing the length of this string. Remember that methods are actions we can perform. That's important. You know, it would not be a bad idea for you to get a little notebook and write down some of the most important things. I mean, if you don't want to do that, you don't have to do it. But it might save you some time. Because later on, you're going to be like, oh man, I don't remember what methods are. Where was that thing about methods? And you're going to be going back through this course trying to find that information. I mean, you can use the cheat sheet. Here we go. There's methods. Methods return information about an object and are called by appending an instance with a period, the method name in parentheses. But I'll tell you, I usually get a notebook and I just write down the really, really important stuff so that I don't have to look it up later. Okay, I want to draw your attention to this little paragraph here. You can find a list of built-in string methods in the JavaScript documentation. So we're going to work with some methods in this little course, but it's not nearly all of the methods. So, you know, this JavaScript documentation is kind of like the instruction manual. And so if you go there, you're going to get a whole bunch of information on all of the stuff that JavaScript can do. And we're just going to learn a little bit of it in the Codecademy course. But, you know, no programmer memorizes everything. They have the instruction manual, they know where to find the instruction manual, and when they want to do something, you know, maybe they remember kind of how to do it, but usually they have to come look it up. Being a good programmer is not about memorizing everything. Being a good programmer is about learning how to use your instruction manual effectively. Alright, use the toUpperCase method. Okay, that dot tells us that it's a method. And these parentheses also tell us that it's either a method or a function. We'll learn about functions later. Okay, so definitely try this on your own. Even though I'm going over this with you, pause this video and try and do it on your own first. Okay, that struggle is where the learning happens. And if you can't do it, we'll come back and unpause the video and you can look at how I do it. Okay, this code is written for us, console.log Codecademy. If we ran it, it would spit out Codecademy over here. But we don't want it to spit out Codecademy the way it is. We want it to spit out Codecademy, but in all capital letters. So we're going to take this string and we're going to do something to it. This is different than the length property, right? When we ran the length property, we weren't changing anything. We were just getting one of its properties. You know, this string, Codecademy, it has a length, and the length property just goes and gets that and brings it back. Well, now we want to actually do something to this. So we're going to do Codecademy dot to uppercase. And you need to make sure that the U is capital and the C is capital. And you need to make sure that everything is spelled correctly or it will not work. And you also need to make sure that you've got these parentheses here. Right now they're empty, but later on there might be some things that we need to include so that this method can do its job. But for now we don't need to include anything, we just leave it empty, but it still needs to be there. So log this to the console, but first make it all uppercase. Semicolon. Looks good. And there you go. All capital letters. Oh, by the way, real quick, you'll notice that this file is called app.js. Hopefully you went and watched that video that I made for you about HTML files, CSS files, and JavaScript files. And so you know that whenever you see something .js, that it's a JavaScript file. Again, if you look in the instruction manual, you'll find a long list, right? Probably like 50 or 60 or maybe even more things that you can do to strings. You can make them uppercase. You can make them lowercase. You can do this to take all of the space out of them. And this can be very helpful, especially, have you ever taken one of Mr. Carter's quizzes where he makes you copy an answer into the little text box and hit submit, and it marks you wrong if you don't have all the spaces correct? You know, that's stupid, right? Because you got the answer right. Maybe the answer is hydrogen, and you type in hydrogen, but you know, you put more spaces in your answer than I put in my answer, and so the computer marks it wrong because they don't match exactly, because the spaces are different. Well, if I had any control over Google Quizzes, what I would do is I would use this trim method to take out all of the spaces, and then it would be a lot more forgiving when you guys typed in your answers, because it just wouldn't look at the spaces. Unfortunately, Google Quizzes doesn't give me any control over that. How can we remove the white space from this string? Well, we just do the trim method on it. Don't forget the parentheses, and don't forget the semicolon. And now you'll notice that it took off this white space here and here, but it still left this space in between the words. So that's good. Actually, I didn't think it was going to do that. I thought it was going to take this space out too, but I guess it knows to keep the spaces between words. Actually, I wonder, what if we put a bunch of spaces here? Would it take those out? No. So this particular function only takes out the white space at the beginning and at the end. So I bet you there's another function. In fact, let's just look it up. I'm curious, so I want to look it up real quick. When you are looking at strings, okay, it talks about strings up here. It talks about making new strings here. You know what I'm going to do? I'm going to use the Control F function. Whatever I'm looking for, it has something to do with white space. So I'm just going to look for white space on this page. String trim. Trims white space from the beginning and end of the string. Well, we saw that already. What else do we got? Trim left only trims white space from the beginning. Trim right only trims white space from the end. What else we got? Well, that is all we got. I can't believe there's no method for taking all of the white space out, but oh well. I won't be able to find that out today. And you'll notice that down here we're in part 9 of 10, so we are almost done with this lesson. Alright, so Math.random gets a random number, and Math.floor rounds it down to the nearest whole number. When we want a random number, you know, we usually want a whole number. We don't want some decimal number usually. And you'll notice that we have put a method inside of a method. You can do that. In fact, you're going to do that regularly. The best advice I have for you, oh, here's a method inside a method inside a method. The best advice I have for you is just like in real math, right? You do the things inside the parentheses first. So you go the deepest one inside the parentheses, you do that first. And then you go outside of that, and you do that, and you go outside of that, and you do that. That's how the computer is going to do it. So that's how you need to think about it. And when you're writing this stuff, sometimes it is easier to write the inside first. And I think that's probably what they're going to have you do here in steps. Assuming you wanted to create a random number and log it to the console, well, you're probably going to end up with something that looks like this at the end. Something that takes a random number, rounds it down to a whole number, and then prints it to the console. And if you're real good with code, you know, you might be able to look ahead and say, okay, well, I want to do console.log, math.floor, math.random times 50. But if you're a beginner, or if you just can't figure that out, you might want to say, okay, first, what do I need? I need a random number. First I need a random number. Now this is going to produce a random number. If you looked at the description, this is going to produce a random decimal number between 0 and 1. How do we get a random number between 1 and 100? Well, we take this random decimal number and we multiply it by 100. And this is, if I click run right now, I just want you to see what happens. But it's going to give me a red X. Ah, nothing came out because we didn't use console.log. Well, let's just keep going. This would give us a random number between 1 and 100. Or maybe between 0 and 100. Oh, so part of our instruction is to log this. So let's go ahead and log it. So see how I started inside and now I'm going outside? Putting that whole thing that I just wrote inside a console.log statement. And don't forget that semicolon. There's a random decimal number between 0 and 100. Now we just take this code for a random number between 0 and 100 and we put that inside of a math. Make sure math is capitalized. I'm going to put that inside of a math.floor method. And see, this is where it starts to get confusing. We need to put this whole thing inside of a math.floor method, but this end parentheses goes with this console.log method, right? I should be able to just space these out here. This parentheses goes with this console.log method. So we want to take this math.floor thing, right? And that parentheses is going to go right here. Now it doesn't actually matter if you put the parenthesis, on the inside of this parentheses or on the outside of this parentheses, as long as you have the correct number of parentheses. But you have to keep track of where this stuff is going. If you lose track and put the parentheses in the wrong place, or if you have the wrong number of parentheses, your code will not work. So now that we have all the parentheses in the right place, you could leave these spaces. It'll still work even if these spaces are here. The computer basically ignores spaces. So I'm just going to run it like this. And we get a random whole number between 0 and 100. Alright, so now they're actually wanting you to go look at the instruction manual. Fortunately, they're giving you a link. But if you go look at the math object instruction manual, we want something that returns the smallest integer. Remember, an integer is a number, a whole number. Returns the smallest integer greater than or equal to a decimal number. So I think that's actually kind of confusing how they worded that, but basically they want you to round up. So if you get a decimal number like 43.8, you want a method that rounds up to 44. So Smallest integer greater than or equal to. Well, let's just try that search method again. Smallest integer. Hopefully in the description it'll say something about smallest integer greater than. Aha, here we go. Returns the smallest integer greater than or equal to a number. I don't know why they got to be so confusing about that. It rounds up. It takes a decimal number and it just rounds up. So what we want is math.ceil for ceiling. Right? You got math.floor, rounds down, and math.ceil, which rounds up. So if we come back to here and do, let's see here. Console.log, we want to log something. And sometimes I do this. Sometimes I just print out one command at a time. And then I go inside here and I do math.ceil. Okay, there's my parentheses. And then I go inside those parentheses and I put whatever, in this case 43.8. So we've got this number, 43.8. We want to do something to it. What do we want to do? We want to round it up. So that's going to round up to 44. And then we want to print that result. So do you think it's going to work? Are you betting on Mr. Carter? Or are you betting against him, that he's going to fail? Yay, it worked. Alright, now I want you to go back to the instruction manual. But they don't want you to go to the math object, they want you to go to the number object. Or am I wrong about that? Math object, number object. Let's see where this link goes. Oh yeah, it's different. This is the number, not the math. Number object checks if a number is an integer. Well, we can use the same strategy. Let's copy this and search for it using Control F. At least on my Windows PC, Control F gives you the search box. Checks if number is an integer. Uh-oh. This sentence isn't on the page. So what we can do is just make it less specific. Now we could just check for the word integer. Number is integer. There we go. Determine whether the past value is an integer. So number is integer. Number is integer. So this method, it looks like, remember methods do something to an object. Well, this method just looks at it and tells us if it's an integer or not. Remember, an integer is a whole number. So, we're going to log something to the console. What are we going to log? We are going to log the number 2017, but we're going to do something to it. We're going to look at it and see if it's an integer or not. And we're going to do that with the number Make sure that I is capitalized or it will not work. I bet you it will not work if it's a lowercase I. Okay. Lowercase I is integer, parentheses. Now see, I typed parentheses and it didn't type a parentheses. And that's because it's trying to help me, but it's actually not helping me. Anyways, you need to get good at looking at this code with your eyeballs and asking yourself, does everything look right? Okay. You need to have as many opening parentheses as you do closed parentheses. And if you don't, something's probably wrong somewhere. There's never a case where you should have 3 opening parentheses and 2 closing parentheses. So, do I have 2 opening parentheses and 2 closing parentheses? Yes. That doesn't necessarily mean that all the parentheses are in the right place, but it's a good sign. So I'm going to take this 2017, I'm going to look at it and see if it's an integer, and then I'm going to print the results of looking at it. If it's an integer, the result should be true, and if it's not an integer, the result should be false. Is 2017 an integer? Is it a whole number? Yeah, so the result should be true, except remember, I'm betting that it's not going to work because this I is lowercase. Let's see what happens. Yep, boom, crash. And it even shows you right here where the problem is. It's telling you that it doesn't like this method. It doesn't recognize this method. It's never seen this method before in its life. And that's because the computer is stupid. Computers are fast, but computers are stupid. Actually, that's not true. Remember, it's people that wrote these programming languages. So computers are only as smart as the people writing the code. And someone decided that a computer would not be able to recognize is integer with a lowercase I. So we have to go back. We have to make it a capital I. And now if we run it, I bet you it'll work. There you go. Notice it did not print out 2017. It printed out the result of looking at it and asking, is this an integer? Well, yes, it's an integer. It's true. This is an integer. Okay. All right. And now we're on part 10 of 10, and you don't have to do anything for part 10. You just have to go over this review. And that's just a review of everything that they talked about in this lesson. Okay, and then click up next, and it'll take you to the next lesson, variables. Alright, I know this video was probably pretty long. I don't know how long it was, but again, this video is optional. You don't have to watch it. I just didn't want you guys to think that I was abandoning you. I'm actually very excited about the things that you guys are going to do in here. I mean, this is some pretty tough stuff, but you can do some pretty cool stuff if you learn how to talk to computers. If you guys want, I will do more videos like this. If even one person requests that I do more videos like this, then I'll do them. So just let me know. Alright guys, good luck.